we should let Scott get started, I guess, if you're if that seems like the right move to you, Scott.
Okay.
I'm gonna
All
mute
right.
us.
Let me just share my screen. Let's see. This is not Teams. And of course, it's shifted onto a different screen for me. Lovely. Okay. Now let me know if this is not going to work for you guys. I'm looking for screen 1. All right. Is everyone seeing Delphi?
Yep. Yep. The text is probably pretty small.
Okay. I'm using a very high resolution monitor here, so my apologies. Do I need to increase the size of the text even more?
Yep. You do, sir. Control
As
plus.
you might be able to zoom in yourself if you double click on the screen in Zoom. It's a bit finicky, but it lets you scroll around. You can drag the screen around and zoom in and out.
All right. Is everyone able to see that code now?
Prefer bigger.
Yep.
Even bigger.
Yep.
Okay. How's that?
Is this looking?
Yeah, that's better, bud. That's better.
Is that looking huge on your end? Is it?
I can only see one character in front of me. It's
A single letter A, the size of 1 foot tall.
yeah, it's sort of like yeah, it's no font size 6,000. What's this? It says current edit font size is 12. I do not believe it. That is not 12. Okay. Let's just see. 26. It's an update problem. If you press the Control Plus button, then it doesn't update. So that's font size 26. So all right. So tonight I was just going to go through one of the fundamental principles of programming. There's a couple of them that sort of survive no matter where you are, whatever language you have. It's just something that is always a good idea. One is high cohesion, and that means that item, whether it's a function or an object or a list or what have you, no matter which language you're using, things that are packaged together should be highly cohesive. In other words, they ought to be very closely related. There shouldn't be anything that's sort of like something that doesn't really belong with the item. If you've got a T television, the one thing you shouldn't expect to see is a wheel. Something like that. The other part, which is the one that we'll be covering today, is loose coupling. Now, if you were to, okay, so coupling is about how tied together all of the different pieces are. Now, you can have strong coupling within reason. Inside an object, things can be tightly coupled, but you really, if you're starting to move away from a single entity of some sort, the desire to loosen that coupling increases. In fact, even within a single unit, if you've got multiple types, those types should not be reliant on each other, you know, unless there is some really strong reasoning for that. So a strong reason for having something which is tightly bound to something else would be inheritance. You've got a class, you inherit from that class. It's tightly bound. Even in that situation, if you were to swap out that base class for a different base class, is it going to break or not? Well, it depends how you've written your code. If you write your code so that you're reliant on certain things being in the base class, and then you swap the base class out, it starts breaking stuff. And this is the whole reason why you want loose coupling, is you want to be able to swap stuff out and have everything still work reasonably well. So in order to get around this, we do things like dependency injection. That's one of the ways you do that. Dependency injection, if I were to just create a class here, and do a constructor here. Now, say my class wants a widget in it. So we might have a T widget. So you could either have in here, we could have my class, have I done something wrong? What have I done? Oh, semicolon. And oh, that's very handy. Okay, so here we go. You can either do create and you say if widget becomes T widget.create, and then in here you've got a property widget. It's a T widget. And up here, right, so that there, you've now tightly coupled T widget to my class, because you've got your F widget here. Oh, I need to put the G in. So you've now tightly coupled the widget into your class here, so that now you're stuck with that widget. In dependency injection, instead of creating the widget here, you would actually remove that and put a widget. You would have a method here. And can we complete that class? Of course we can't. Why would they add that feature? And I can spell right eventually. All right, so now we're passing through a widget. So that allows us to be uncoupled. The widget is created so that when we have, say, we'll just put into our form here. Actually, we might need to move these things. All right, so we just put in a procedure here. In make my class, we have if my class becomes T my class dot, is it my class? Yes. Dot create, and you pass through a T widget dot create. So what that does is you can pass, you can generate the widget here. If I can find my cursor. Okay. So you can create your widget at this point here rather than inside your class that decouples one from the other. If you then have descendant class as a widget, you can decide inside make my class which one you want to use. We could take it, another way to do this is we could do my class equals class of my class. And we can change the constructor. Oh, where is it? Constructor. Oh, sorry. No, I don't need that one. I need widget class equals class of widget. And then you can pass in widget class. And in here, and then you've got the option, if you do that, then fWidget doesn't necessarily need to be created here. You could store the widget class, or you could actually use the widget class here. Where is it? Widget, sorry, class. So this is how you would instantiate the widget without knowing what sort it is. And the benefit of this is if we want to instantiate the widget at some later time, then what we do is we just store that instead of the widget. Well, there's the widget, but we can also have a if so we're now going to store the fWidget class, and then we can have a procedure in here. fWidget becomes fWidget class.create. Now, the one thing that this does by doing it this way here is that we are completely dependent on having a particular pre-established constructor, which, you know, that might be fair enough, but it also means that if you polymorphize your widget so that there's multiple constructors in descendant classes, each one perhaps having different parameters that you'd pass in, this here sort of breaks down.
Scott,
So, yep.
do you mind if I pause you and ask some questions?
Yeah, sure.
I don't want to break your flow if it should be later.
Go ahead.
Okay. So the class of a class is, I mean, someone was just answering it
Is
on.
here?
Yes, someone was just asking about it on the forum, and
Yep.
I've only sort of like partially got my head wrapped around it semi recently. So so you've just shown us like sort of like two different versions of the subject you're talking about, right? Just now we had the
Yeah. So what we're trying to do is, rather than having your widget created inside my class, what we're doing is we're injecting the dependency which allows us to basically have something else foreign coming in, deciding external to our external to my class what it is that's going to be in there. And the only thing we've got as a contract is the T widget class. So if we were to take this and put this into a different unit, then we could swap one unit out for another unit. As long as there was a T widget in there, everything's going to be hunky-dory. It's pretty loosely coupled because we're not relying, as long as it meets what we're expecting here, everything's good. This thing here is all happy. And in this case here, we're even saying, and we don't have to create it right now. We can create it sometime down the track. So the class of in front of a class means that instead of referring to an object with this class, so something of type TWidget is referring to an instantiated widget. In the case of TWidget class, what we've got is essentially a pointer, a typed pointer to the TWidget class, which means that it can then be instantiated. So here, where we do TWidget class.create, that is entirely equivalent to if widget becomes TWidget.create. So those two lines are functionally the same at the moment.
So
because this here is storing TWidget. It's not storing an instance of TWidget, it's storing a pointer to the TWidget class itself. So fWidget class variable is interchangeable with TWidget.
I have a theory in my head that I don't know is correct or wrong, so I'd like to ask if you don't mind.
Yeah, go ahead.
So the way we had it first, the constructor was taking a okay, let's imagine widget
Okay.
is like household items or something, right?
Yep.
And then
so originally that's what it looked like.
Yeah, and the constructor was going to take a widget, so that means washing machine or vacuum cleaner or fridge, right?
Yep.
And they're all instances of widget, like they all are in the same class, right?
So what we're doing is that, so we were creating the widget and then we're passing the widget through.
Yep. Now, if there was a descendant of widget that was like kitchen widget, for example.
Yep.
You could you pass that in where it wants a widget?
Yes.
Oh, okay. So my theory was wrong.
Okay, so you've got your TWidget class here. We can descend from that. So kitchen equals class TWidget. So now we've got our TWidget class, which is a descendant of TWidget, which means that this here is also a type of TWidget class, which means that since we've changed the interface here to accept a TWidget class, then when we go here to instantiate my class, we can actually put in here kitchen widget.
And that kitchen widget would have worked in both of those examples that you've shown us, right? Is that correct?
Okay, so the previous one, I would have to have instantiated it. So when we were just passing through, instead of a widget class, if that was just TWidget, then I would have to instantiate it and then pass it into the constructor.
Yep.
And in which case it would look something like this. So now we've instantiated it, we can pass it in. But what that means is that we are forced to allocate the memory right now.
Yep.
We must have.
My first and wrong question was whether using the class of allowed you to, like get that down the hierarchy polymorphism, but that already existed in your first version. And so you're using class of, it means it's like pushing down it's giving you like you were saying, you can create. It's like a lazy, like
Oops.
evaluation. You can do some
Oh, yeah,
work at a later time. Is that right?
yeah, lazy construction. So if we do this, so we've got a T-widget class is a class of T-widget. That means that this here can store a T-widget or any T-widget descendant. So that value will be the class. It won't be an instantiation of the class, which means in this case here, we could do where is it? If my class 2 becomes T my class dot create T widget. So in this case here, we would have my class has now got a kitchen widget in it, whereas class 2 would have would my class can instantiate a T kitchen widget, and my class 2 instantiates a T widget. It's the same interface in both cases because we're just passing in a class of widget, and kitchen widget is a class of widget.
Okay. Okay. So yeah, I was just trying to clarify that the first approach you were using, you have to hand it an object, and this time you hand it a class, a type, and you can do stuff with it later on down the track.
Yeah.
Right.
Yeah,
Okay.
that's precisely it.
Thank you.
So this way here, the only difference between the last two ways we did it is that this here, we decide when we want to instantiate that other widget, because what we're doing is the method of constructing that widget is being passed through, the class that allows you to construct it is being passed through rather than an instance. If we did it the other way, then we would have to instantiate before sending something through.
Okay, thank you very much.
And that may or may not work for you.
And
Now,
I think when I interrupted you, you were going on to talk about if there were multiple constructors or something.
Yep. Now, so how do you decouple when you introduce some polymorphism and say there's now more constructors? Well, the way you do that is just like class of widget is an abstraction away from just using T widget, so that we can then have more flexibility over when we instantiate. There's another way of choosing to mask the way that you construct, and that is that we create an anonymous method. So T widget function equals, and because it's going to be an anonymous method, reference to function, and we don't want to pass any parameters in, but it's going to return a T widget. Ah, yes, we'll need to do that after we define what a widget is. So there we go. A T widget function reference to a function that returns a T widget. Do we need any parameters? Well, it's an anonymous method, so probably not. It just means that when we create it, wherever we create it, it needs to do whatever needs to be done. So now we've got our widget, which has got a regular constructor. So we'll just type in here, public. And so with this one here, we want the manufacturer of the widget. And then we have in here, we will have public and then in here we'll have the manufacturer, which is a string, and we will also have a category, which can also be a string. and we'll do overload so that we can have multiple different ones. The squiggly line there is just saying you haven't instantiated. But the point is that we've now got two different constructors for kitchen widget. One, which is this one here, where we don't specify category, and this one here where we do. Now, this may or may not work for every descendant class, but because we've now got a twidget function which returns a widget, we don't need to care about that. Because what we'll do is when we go to create, we don't want to send a widget class through. We want a widget function. And over here, we'll change that to widget function. And this here, widget function. Then when we make the widget, whoops, instead of widget function create, we call if widget function with parameters there, and that generates one. So the anonymous method is responsible for making the widget. So here, this needs to be the function. That there just to keep everything aligned. And then we don't want that. Right. So now what we're doing is we're storing a widget function. Now the big difference there is instead of creating here, we can create with a function. And this one here can be twidget.create. My manufacturer. And then here, we create with a function. And it's tKitchenWidget.create. And in this case here, we want the widgeters can be the manufacturer, and the type can be egg beater.
You need a result equals there.
Yes, I do. All right, so now our function, hold on, we also need to have a return type, which is twidget. And that also is twidget. All right, how are we looking? Okay, that's now looking pretty good.
Would you put that as widget or kitchen widget, Scott? Does it matter?
So kitchen widget here, kitchen widget has a constructor that has two parameters. Twidget has a constructor of only one parameter.
Now, Scott, where are you? Line 78. You've got a
Yes.
few red dots there. Could you possibly get rid of those? Because when I go through this, that they will confuse me.
Yep. There's going to be a few of them because I don't think I've created my class either. Is that the right place? Make my class is part of form 1. Okay, so in here we can do team my class. All right, so that gets rid of all of our squiggly lines.
Yep, thank you, sir.
Would it be possible for F my class 2 for the return type to be a kitchen widget, or would that be unproductive?
No, can't do it because we've said that we're passing through a particular anonymous
function
method.
signature.
So that is the anonymous type, from
Right.
anonymous method type. So it needs to be t-widget. If we were to do t-kitchen widget, this would fail because this here it needs to be of the exact type.
Okay, that's interesting too.
So this here, now because it's an anonymous method, you can see what I've done here, but because it's an anonymous method, we can actually do something like this, where we have, and maybe just make that lowercase. My convention is local variables get lowercase at the starting letters. And then in here, we can have and category becomes probably one word, egg beater. So now we can do man, and in here, man and category. And because these are anonymous methods, they actually capture stuff outside. So we don't actually need parameters as long as we do it this way. So here, make my class is the knowledgeable one about what's being made. And the tmy class is agnostic to what comes into it. It doesn't even care how it's constructed because the constructor is also being abstracted out. All you care about is that it's going to be storing a widget of some type. So there we go. All of that is now functionally correct. You can do whatever you need to outside, and as long as this holds true, that when you're creating something, you create that t-widget and whatever else, so long as you meet the criteria of this anonymous method, you can put anything in there. So that's getting pretty loosely coupled now. You can't really get it less dependent. Of course, we want to take this stuff out from the one unit. I mean, at the moment, it really doesn't matter how we do this because everything is sitting in the one unit. But what if it isn't? What if we start distributing stuff out so that we have like MVVM? You want to separate your concerns out. So we've got our classes in one spot. We've got our UI in another spot. How are we going to get them to talk and still be loosely coupled? Well, there's no way around having it reference something. But have you seen any units where the number of classes that you're referencing are there's just like 50 or 60 classes in your reference? I could probably show one of that. I inherited some code. I'm pretty sure that this is not going to worry people too much if this gets displayed. But what I'll do is I will just create split split bottom. I'm just doing some stuff off site for a moment. Okay, that's going to be tiny. So I'm going to have to zoom that up as well. Okay, so here we go. So this is from some code that I inherited. And this here is your users clause. Everything in this users clause is part of this application. We see a whole bunch of forms, we see a whole bunch of classes, goes on forever. That's a lot of coupling. That means that if I wanted to swap something out, I have to go and make a whole bunch of changes around this area here in order to get that happening. And it's like, okay, well, that's fine. I don't mind making a change here. What if you have dozens of forms and you wanted to change one unit for another unit? It means you've got to open up every form and change out each reference of one unit for every reference of another unit. Now, if you miss one, you've got one pointing to your old code, one pointing to your new code, and if they're both referring to the same class, you're going to have some real problems if those classes are different between those two units. So that's potential errors just waiting there, and they'll be really, really hard to detect. So what do? We've got to clean this up. And what we do in order to clean this up, so I'm just going to close that, is that we have, now I've called this spc.interface because this is the single point of contact. In this area, you have all of your contracts for everything that's going to be interacted with. Now, maybe you have more than one of these, then it's multiple points of contact, but you can still have, say, one that does all the interfaces for one aspect of your program, maybe all of your forms. Another one might be all of your graphical generator units. Another one might be all of your logic units. You can still have multiple of these, but the idea is that you've got one single place that is then referenced elsewhere. And then what you do is you have your interface contract. So this here is the pattern. The pattern here is the factory pattern that I'm implementing. So up here, we have our contracts. So it could be an iWidget, another one that I was in the process of making, iBase dialog. So all of our dialogues are going to have an interface associated with them of iBase dialog, which means you can do certain things. And then after all of your interface contracts are set up, the next thing you do is you make your anonymous methods. Now, in this case here, this is a trivial anonymous method because all it's doing is just producing an iWidget. Now, what that means is because it's trivial, there's no parameters or what have you, we don't need to make dozens and dozens of this here. It doesn't need to be specific to one particular type. You could just as easily have called this t_no_param function or param widget function, and that would be just fine. Everything that returns an iWidget and has no parameters could use this. That could be a dozen different interfaces. So yeah, you don't need to actually have one of these per, but if you wanted to have parameters here, and I'll show you a reason why you might want to in a minute. But as long as you don't have any parameters going in to create this function, that is your creation function. Now this here is the same as what we were doing just a moment ago with our widget function here. It's exactly the same idea for exactly the same reason. But what we've done is we've put that anonymous method type into this SPC interface or single point of contact interface unit. Now, one of the characteristics of this unit is that there is little to no code. there's going to be lots of stuff that sits in above implementation, virtually nothing that sits between implementation and your next section or the end. There's usually nothing, it usually doesn't have any other sections either. So the only things you would expect to have here is code that manages your factory. So after you've got your anonymous methods and it's returning a contract, we then register or create something to register. Now this one here, I'll need to change something back. One moment, I'm just going back to where I renamed. There we go. That'll get rid of the squigglies. All right, so this method, this anonymous method type is passed through in registration. So the two things that are passed in is the identifier for your factory and a function that produces whatever the factory is going to produce. And then the widget factory is a function that just generates a widget. So it returns the widget that you want. And in here, you've got the reference to whatever the name of that widget is. Now, in the code, let's go to register widget for a moment. Register widget. Now, there are two ways to do this. One way is you could have another section in here, which is initialization. What have I done wrong there?
IAL.
Initial.
Hello.
There we go. Can't spell. All right, initialization. So we could do that, and we could take this line here and put that into here so that the G widget factory thing gets generated first. This way here is it's the lazy loading or lazy instantiation method. You don't bother creating the widget dictionary unless you're going to use it. Now, this could lead to an issue, so we're just going to modify this code here. If widget dictionary and that's better, that's safer code. So what we're doing here is when something gets registered, the name or the identifier comes in along with a function that actually does the work. And what we do is we store them into a dictionary. So I'm using the Spring framework here. Highly recommend the Spring framework. Stefan Glinke does a great job in keeping Spring up and going. One thing I will say is that don't be caught. There's two versions of it running around at the moment. Version 1 is not compatible with version 2. There's a break in compatibility between the two, and it will take you maybe 2 or 3 hours, depending on how big your application is, to run through and make all of the changes that potentially could occur between the two two code bases. In Stefan Glinke's Spring framework, this here is another factory. So this is the collections factory, and you're asking to create a dictionary, and here's your generic types that you're making. And it's got the string and the function stored in the dictionary. Now, the way it's stored, this is something that's new to version 2. In version 1, it would be slightly different to this. So that this is version 2. Let's just keep this on the screen. Spring Framework version 2. And the other one is widget factory dot add or set value, and then you would pass in a widget name and the AFN, and let's just make this a little more readable. Right. So the big difference is add or set value, I think, is deprecated, which means that they're trying to get rid of it. And instead, what you do is you just do this. And the way that this works, that's like you're doing a reference to it. But in the case of the setter, it says, does widget name exist? If it doesn't, then we add it. If it does, then we just override the value that's being passed through. So it's functionally equivalent in version 2. This one is functionally equivalent to this, and this one here is marked as deprecated. All right, so we don't need 2 of them. We'll just get rid of that. Right, so that is what puts the object into the dictionary, or the constructor into the dictionary. The way we extract it, first of all, we want to check that the dictionary is actually there. If it is, we then check to see if it contains the widget that we're hoping to find, which is the ID that we're passing through. If both of those things check out, then notice these round brackets here. We're calling a function, and the function is the one that was passed in here. So the anonymous method, I should say. So it's calling an anonymous method for the one that's registered under the given widget name, and it generates it. Otherwise, it returns nil. Nil's a valid value for iWidget. So we're all good. You create it. You may or may not get something. If you do, it's whatever you've got. And the beauty of this is that when you go to put in more functionality or remove functionality, the way you do that is by adding or removing a unit from your project. So in this case here, we're going to register our widget, and this widget is going to be called, let's see, we'll call this widget descendant equals class base class.
Scott, does Spring have any way of like sort of a function for detecting what version is running? You're using?
I have. Oh yes, there is. There is a compiler directive for it. I can't remember it off the top of my head. But yes, there's a compiler directive so that you can put the 2 different types of code in there.
Okay.
And yeah, that'll get you past. But yeah, I can't remember off the top of my head what the compiler directive is.
Thank you.
Yeah, Stefan's no rookie. He knows how to do this sort of stuff. All right, so we've now got a widget descendant. So the way we would do this, when we're going to register the widget, notice that we're using the single point of contact, and we're calling the register function in the initialization section. Initialization, I managed to spell it right once. Okay, so what we'd do this here is we'd say WD could be the ID. So that's widget set desk is WD. So that's our identification in here. Now we don't need any properties going in, or sorry, objects going, parameters going into our anonymous method. So here's our anonymous method function with no parameters, and in here we just replace the nil with widget desk dot create. So then we could register more and more. We could even register the same one with a different ID and maybe do additional stuff inside the anonymous method. But yeah, usually what it ends up looking like is you're registering every ID with a function for a particular class. So if we've got T-widget mutant is a class of, and we could descend from either of the ones above, but we'll just do T base class. And we can now register in here. And in here, mutant. And the function is going to return an I widget. And in here we do results comes T widget mutant dot create. And that's sort of like the minimalist way that we could do this. And as I said, because this is an anonymous method, you can put lots of lines of code in there. I do recommend, I mean, this is nice if you're going to be just doing a list of lots of registrations here. But if you're going to do something that's a little more complex inside that anonymous method, I do recommend doing something like this instead, just so that you can read everything that's going on. I mean, this is, you have to admit, this is more readable than this one above. But if you've got like a dozen of these going down the page, doing it this way here, if they're all very simple, it's following the same pattern sort of thing, actually does look neater, and you can actually follow it a little easier than having a lot of these sort of indentations and bits and pieces. So either way, still works. So we've now registered two different classes. And what that means is that we've got WD and mutant. We can go back to our main form again. And back in our, let's see, in our dependence injection, we could actually change this up again. So just so that you can see the difference with the factory that we're doing, my class factory edition, and what we pass in here is a ID, and that there is string, so that we can still get to choose what it is that we're creating. And in here, we'll need to create all of those things. We don't need that anymore. And inside my factory, now this is what we do here. And in here, we have if widget becomes, and then it's factory, no, what's the name of it? Here, widget factory, that should have come up. Widget factory, and we do, whoops, AID, and that's how we're creating it. Oh, sorry, FID. And in here, just call it FID. So that should now be hunky-dory. What's wrong with this? Oh, we're creating an I widget, which means it's not a T widget anymore, it's an I widget because it's an interface. And that of course means that this would need to be an iWidget as well. Okay, so now the few things that we've made changes with, and we can compare the two here. One is that when we pass something into our dependency injection, is just an ID reference. We may or may not need to do that. We could actually just use the string constant wherever, and maybe that's a good idea too. If we go back to here in our users clause and what have you, maybe we do somewhere in here, just like before type, we can have const, and then we have and widget, sorry, what was it? Widget descendant equals WD. So now we've got constants. We can use those constants here. So now we've got a constant that ties everything together. And of course, the thing about the key is so long as you've got a type, you don't actually, well, it doesn't have to be a string. You could actually have an enumeration. Anything that can uniquely identify and can be used in the dictionary in here. So in this case here, what we've got in our dictionary is a dictionary of string. If you were to make custom enumeration, you could put that enumeration in here instead, and it would just be something that could positively identify a particular class. So there's lots of different things you could do this. I did try at one stage using an interface. So you'd pass in the interface and it returns an instantiation of that interface. Thing is, it's a little tricky. In order to get the interface into generics, you've basically got to call it a GUID, and then you've got to take your interface, turn it into a GUID in order to both set and retrieve. It's a bit complicated, so probably not for tonight. Don't want anyone's brains to explode. All right, so where were we? Yes, so it's a string in this case here.
You're making the assumption that they're not already exploding, of course.
Well, okay, yes.
We're just quietly bubbling along.
Okay, but yeah, in other words, what I'm doing now is something that hopefully you'd be able to follow. Yeah, maybe you watch the recording twice if it's not making sense the first time.
It's been really great, Scott, because I mean, I'm sure you've covered some of this sort of thing before, but like if we're in the Artifactory and it's on the, the television, I think like it's a real advantage being able to see the screen up close. I think anyway, to like, oh, okay.
So what do we call that one up there? My class fact. Dot create. And in this case here, we want an ID. So in this case here, because we've now got a constant, we can put in mutant. And then, well, we'll assign it to whatever we need. And up in here, is it, yeah, is that correct? Yep. Okay, so now we can see this one here. Actually, no, we don't do it to my class fact. What we do, oh no, it is. We're doing a my class fact, but what we're doing is we're passing in the ID, and when we get to the ID, we're using the widget factory to do the instantiation. Now, what that means is that my classes here is actually registering mutant. But if I take this unit out and well, the first thing, let's just say I take this unit out, what happens to the other code? If I take it out, everything still works, but in this code here, it returns nil and fwidget is nil. If I then put a new class in, replacing my class, and my new class registers mutant, then what will happen is that instead of getting this one here, you will get the alternate one, and this class still works, producing whatever that other item that's been registered into the factory is. Further, you've got your widget, which is a type of iWidget, but you don't need the only thing that you need in your users clause is your single point of contact. So single point of contact here, a single point of contact where your definitions for all your classes are, or there may be dozens and dozens of these classes that all use a single point of contact, and they all roads lead through Rome. Rome is our single point of contact unit, which is this one here. And like I say, this one here, it's got all the definitions. It can have all of the constants in it. It can have all of the interface contracts in it. And also it'll have the registrations and the factories. So this one unit, you might have a dozen factories in there, and you would have a dozen registration units, or maybe even more. Maybe you register, maybe there's multiple ways of registering for the same widget factory, because if you're, say if you wanted to have a function that had a parameter in it, what you would do is you go in here and you would have some sort of parameter. So in the case of the iBase dialog, we want a T dialog maker function is reference to function, and then in here you may want to have some properties. iBase dialog, and in here you could have something about, well, maybe you've got a choice about whether it's modal or non-modal. Maybe it's a choice about, let's see, you could pass parameters in here, or one that I generally use is something along the lines of, because this is, say you're doing something that is typically going to be like a modal dialog. What I would have in here is I would have some other sort of properties being passed through. So, but you, one thing you do need when you're doing dialogues is you need the owner. So you do const a owner, and it'd be a type of T component. So that's like the basic thing. If you're going to do a form, the form needs to know what its owner is. I think we need in here classes. I always do the Delphi ones before everything else. System classes, does that work? Yep, T component. So with this one here, when we register, register dialog, I'll just call an AID, just string, and the other thing that we want, oh no, that's all we really want. And, oh no, we want the function, which is a T dialog maker function. But when we get to the factory itself, T dialog factory, AID, just the same as we doing last time, but we actually want to pass a component in here. So we'll do a owner type T component. And that returns an I base dialog. Now we've got the squiggly lines there because I haven't made the what do you call those? The implementation. Just grab that one as well. Now I'm just putting these here, so I'm grouping the registrations and the factories together. You don't need to do that. You can put them in pairs so that you get all the widget stuff together, all of the dialog stuff together. It's all down to personal preference. But we're going to do the same lazy loading. G dialog dictionary. And dialog base. Oh no, sorry, it's not dialog base. It is that function. And in here, same pattern as before. If not assigned, G dialog base function or dialog dictionary. Oh, it doesn't need parameters. What it does need is string and T dialog maker function. AID becomes a function. So again, you can see the pattern, this pattern and this pattern, exactly the same sort of thing. And down here is going to be a very similar thing, but remember we've got an owner as well. Hold on, that's supposed to be a string. I think I did something wrong there. Yeah, the ID should be a string. My mistake. And in here, if not, or if assigned, and G dialog dictionary dot contains key AID, result becomes G dialog dictionary dot passing in AID, and then in the parameters here we want the owner. So notice the difference. No parameters in this case, one parameter in this case. Oh, hold on. And else result becomes nil. So there we go. We've now got our dialog factory. And just to drive the point home, why is that a problem? Did I spell something wrong? T dialog maker function. T dialog maker function. What have I done wrong there?
Scott, it should be create dictionary, not just create.
Ah, that's right, you are correct. Create dictionary. Yeah, it's better. All right. So we're now this here and that there are precisely the same, following exactly the same pattern as before. In this case here, they're almost precisely the same. The one difference is that we have another parameter here, and that is passed in as the parameter to your anonymous method. And at the same time, if we go upstairs, you'll notice that we've got our iWidget with no parameters here and the A owner there. So whatever you put in here goes into here. And yeah, maybe we want to do a const. All right, so that's the main difference. This here is because of that there. So now we generate our what do you call them? We generate our forms, and our forms become instantiated with an owner, which is a really good idea. And then here in my classes, when we register something like that, so let's just create a new form, create a new form, and in here we're going to say that the form is $base, oh sorry, it's base dialog, isn't it? Base dialog. Up here we need the single point of contact. And the problem that it's now got is I need to have the implementations of all the things that we just signed up for. So I'm going to go to, where is it, my interface here, and say, I need those things. So in our new unit, throw those things in, automatically generate stuff, and it's the implementation of set prop. No, we are not. Set prop is right there. I'm not sure what the problem is. Do we need system variants in here? Okay, let's just check that set prop looks the same here as it does in here. Aha, forgot about the const. Right, so that'll solve that. Okay, so now we've got our form, which is implementing this interface. Everything's good here. We've got the SPC, single point of contact, in there. And in the initialization section, we do register dialog. In here, we're going to have my form, and that is a function that needs an owner of T-type component and returns an I-base dialog. And in here, and of course we've got the AOWner parameter from here. So that's how it passes all the way through. So now we've got our register dialog done. We're all good. We don't need this anymore. Just make sure that you also go into your project and tell it not to create this form automatically, because now what we're going to do is we're going to use the dialog factory to generate it. So there's this way we can have forms that call other forms, but the only thing you need, okay, let's take my form out. my form, go into a single point of contact, my form equals that. So now we've got something that's registering under my form, so that we could actually do in here, we could go into the form one and just chuck a button in there. Actually, we'll go into that code there. Oh no, we'll use another one. New button. Where is it? Button. And in this one here, we do if my form becomes dialog factory, my form self. In this here, it's going to be I base dialog. So that when we go back down to the button, right. So you can see that this here will call the construction of dialog factory, or that it'll call the factory thing that opens. So, and then we can do, because we've got a method there, my form show, and that'll create the an instance of that dialog and show it. And notice that unit 2 is not in the users clause of this main form. So this main form doesn't actually have to know about anything. When that button gets clicked, all it needs to know is that if there is something, hold on, maybe we need to do one more thing here. If assigned, if my form, then show it. Now we've got a foolproof way of either opening the form or failing to open the form and failing gracefully, so that we can then plug in whatever that form is, and all that has to be is a unit that registers the form at the bottom there, and we're good to go. How uncoupled do you think that feels? All right. So what that allows you to do is you can swap one form out for another. You can swap out one piece of logic for another. And all you need to do to connect everything together is basically have a contracts page, which is your single point of contact that everything uses.
So unit 2 is still a visual unit, right? So got a form aspect and a code aspect. Is that right?
Correct.
Okay.
If we go back to unit 2, got procedure show. I think show already exists, so I'm just going to get rid of that and get rid of those 2 lines of code there. Show already exists, so it's already being implemented because it's a T form. So all we need to do is implement or put some code into these other areas, or well, at the moment we could even leave it blank. It doesn't really matter. But I just find that there's things that I generally do that mean that I have this way of getting information in and out, and I generally make something that's a bit slicker than just what we've seen with that factory. But the general principle is there. We've now got something that will actually work. So if we go into the main form, providing everything compiles, okay, so we've got a problem here with this constructor because we haven't finished it off. So we'll just code here. And this one here. All right, so now that we've got all of that, we can actually create this thing. Hold on, it says there are errors. Where are our errors? Ah, yes. I did tell you we needed to get rid of that. All right, now where'd that main form go? I have no idea. Oh, here we go. There's our tiny form. And then we're just going to click this button. And there is the other form that we instantiated that we just called without the main form using that other form. And yet it was called from main form. So that's the power of these factories.
And the second form is owned by the first form, is that right?
Yes, because we passed in, if we go back to our,
Yeah, self.
it's going to take a moment. Oops, where are we? Okay, so our button here, the widgets, oh no, not widget factory, where are we? Form. Here we go, and we passed in self. So self is an owner. So neither of them know about each other. One of them owns the other one. Neither of them have the users clause of the other in its user state declarations, or what is it, unit declarations. So what that does, it completely removes dependencies. The other thing is, because of the way I set up my form, I can do if my form dot prop, and then I can do caption becomes caption. Got a caps lock in there somewhere. So we can do something like that. And in here, we've got case. Now, this is something that I do here. Anyone use strings? If you've been following me for a while, you'll know about this one. You can use strings in case statements. Index text, a prop name. And we just need to, in here, now I like to keep all of the system stuff at the top. String utils has index text, which is a non-case sensitive method. And in here, we're going to put in here caption 0, and I tend to do this as well, just so that I've got some record that this one here lines up with that. And then we do caption becomes equal to value. And we can make that more secure by making this bar2 string. So there we go. Now what we can do, if we go back to the main form, is that we've got this prop here, overridden caption, so that when we run it, and sooner or later it'll turn up.
Maybe it's on your monitor number 16.
Yeah, here we go. So we're going to need a magnifying glass, so I do apologize for this. If we open that up here the title says, and you'll just have to trust me, it says overridden caption. And because the way this works, we can just keep on doing all sorts of funky things, storing other information in that, because we can actually create a dictionary of it. So in here, we could say else if f props. Actually, no, we're going to do this. Becomes value. We're going to use Spring in here. And in here, f props, which is an I dictionary of type string, comma variant. Now, you don't have to use variant. I'm using variant. If you want something that's a little more flexible, but a little bit more pedantic about types, you can use a t-value, in which case you would have to add in here, I think it's RITI or something like that, system.RITI, in order to get the t-value class. But yeah, t-value class, you can add anything. You can add methods in there, you can add objects, interfaces. T-values can store practically anything straight off the bat. It's a little finicky about getting stuff out though, so you know, let me say you've been warned. I'm actually using it, and it is a little more finicky than variants, which are very they're almost duck typing.
Sorry, which one was more finicky than variant?
T-value.
Ah, right.
Yep. So that's in the system.RITI unit. And yes, it's rather difficult to use because as you extract stuff, you've got a contract. You extract stuff as string or as integer or as extended. So getting stuff in is reasonably easy to a t-value because it has a lot of implicit casting. But implicit casting only goes one way, and that's in, not out. So when you're trying to pull something out, you've got your t value, and then you've got, in order to get your t value out, it's got to be, you know, my t value dot as string in order to get a string out.
You're saying you want to know the type that's in there.
Yes.
Right. Rather
yeah,
than
and
just
now,
give me what you got. Okay.
yeah. Now the problem that you've got is that the thing that dictates the terms is the first, you know, the one that puts stuff in, which means that if you've got a form that's trying to export stuff out, then it's dictating the terms because it's dropping a value into your dictionary of t-value. And so your form can say, okay, I'm going to, you know, put the result of my calculation in here as an extended. It does extended. It doesn't do double or single. It's just extended for floats. So you can say, I want this as a float. I want this other thing as an integer, and I want something else as a Boolean. And all of those go into the system. But then on the other end, you need to have some idea about what's being stored in those values, so that you can say, what calculated value is as extended, and the index is as integer, and the switch is as Boolean, and then you pull it out that way. The trouble with that is that you've lost some information because it's a t variant. Oh, sorry, a t value, and so therefore the information is not implicit in the code anymore. So you're pushing data in and you're pulling data out. The two sides have to know the contract that they're dealing with. It's sort of like, I know that calculation is always going to return a floating point number, and I know that index is always going to return an integer. So so the two sides actually have an implicit contract in there, which is adding a level of coupling, but without the without any type checking between the
Well,
two.
that leads me to a question that could throw this off track. So don't need to. I've written it down. Don't have to answer it now. And I may have asked you this question on the phone after last meeting.
Yeah.
But so we can have an array of no. Can we have an array of types? So if I want an array that, like for that instance, I want to save the value into a t value, but I want to save the type somewhere. So maybe I might have an array of
Well,
integer, string, t kitchen widget, blah 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 blah.
all in the same array.
In an array, yeah.
Yep,
Can we do that?
I would recommend that's an array of t value. You could do
But-
it with something like a t variant as well.
So like the difference between
Yep.
class of t widget versus t widget. So
Mhm.
one's about values and one's about types. Can we have an
Yep.
array that stores types? I mean, maybe with class, something descended from T object
Yeah.
is maybe easier, but what about integer and string and double and extended and stuff?
Yeah, unfortunately, those fundamental types, the only thing that you could actually do is you could go into RITI, and RITI has a type wrapper. So if we just go into RITI at the moment,
I don't want to throw you off track for your talk.
no, that's all right. Okay, come on, you Control Enter.
I mean, I guess in a bastardized way, we could like have an array of values, like array of const or something that represent the type that they are, maybe, but I don't know.
Okay, so I'm trying to remember what it is, but there is something in here that is, I think it's TRITI. There we go, TRITI type. So that's the way you would store types. So T value would store the actual data, but if you wanted to store types, that's TRITI type. And TRITI type is a class with all of these lovely properties. Now, let's see, the interesting thing is,
I think I was actually looking at this at one stage.
yeah, so this one here, it looks like it's actually trying to return a value, which is sort of interesting because it shouldn't. But yeah, I'm pretty sure that TRITI type is what you're looking for to do what you're asking, Paul.
Can you, if while we've got it there, would you mind searching for that string?
What's this TRITI type?
Yeah, if you don't mind, and
Where are we searching?
just in this unit. Does it come up in a billion places or just?
Yes, it does.
Okay.
Okay, so the interesting thing about TRITI type is it looks like it's a base class because, okay, so you've got all these here, T function, returns a TRITI type, returns a TRITI type. But if we go down here, this is really interesting. You have TRITI class ref type descends from TRITI type. TRITI enumeration type descends from T ordinal type, which is probably somewhere up here. And that one probably descends from TRITI type. So there we go, TRITI
Decouple
type. So TRITI ordinal type descends from TRITI type. So all of these things descend from TRITI type. But so what you do is you just ask if your variable is a TRITI int64 type or is a TRITI ordinal type. Although I think if you look at t-ready type, there's probably a function that already does that. So if you do, there should be a few is instance. That's a key one because that's telling you, am I dealing with an object? If it returns true, you've got an object. If not, then you've got something which is not an object. Is ordinal means that you're dealing with something that's either an enumeration or an integer of some flavor.
Yep.
Is record, is set. I love how they break the pattern here. As is, as is, as is as. Yeah. Is
So it's probably
HFA.
because that line is short. I didn't want to finish with the short line.
Yeah. Okay, is HFA. What in the world is HFA? HFA, please, someone tell me. Does anyone know what HFA is?
Is it somewhere further up?
It obviously thinks that we know what that acronym is.
FA.
HFA. Highly flexible array. Health and fire administrator.
Something fixed array?
I don't know. I'm not
Yeah.
even sure if it's array.
You need a dictionary for the dictionary.
Heap fixed array on maybe?
Could be. I don't know. It knows. Maybe there's some help on it somewhere. But yeah, I'm at a loss. But you'll know if you've got an HFA. Is it an let's write a program. We'll just shove everything into this thing and then ask them all, are you an HFA? And the one that returns true, we know what it's talking about.
This might be one of those things where if we went to like not Borland, Embarcadero and asked everybody involved, like, does anybody remember what HFA is? Like everybody starts looking at each other like,
yeah.
Well, I think that's before my time.
I think you're right. I think it is something about an array because now you've got HFA element type and element count.
Well,
So,
ChatGPT says it's a homogeneous floating point aggregate.
it could be right. Then again, it's ChatGPT. It could be wrong. ChatGPT, the Wikipedia of AI.
Looking at the wiki, it's for internal use only.
Yeah.
Indicates whether the reflected type is HFA. If I click onto the HFA link, HFA is holds the HFA information for the gold.
Circular.
For internal use only because they're not letting on that everybody's forgotten what that means.
SHFA is true if the following conditions are met. The platform is ARM64. Reflected type is a structured type of record on an array. All fields of the reflected type are the same floating point type, either single or double, e.g. And the number of fields is 1, 2, 3, or 4.
Okay. Fine.
So it's a tightly defined specialized type for ARM64.
Well, that's what ChatGPT basically said it was.
Okay.
It says it can be used to optimize storage at calling conventions, especially on ARM and ARM64 platforms.
Okay, so it's something like a specialized type of pointer.
It's
like
got where
a 64-bit
HFAs
pointer
are sometimes passed in floating point registers where rather than on the stack for efficiency.
Okay. That sounds right. So it's basically a glorified pointer.
There's HFA attribute in system.pas. but I don't think it tells us much.
All right. Okay, so cool.
Tangent. Yay!
Yay. I am now Ronnie Corbett, and we have diverged 2 steps away from our original story.
Sorry.
So, with those functions that you'd created there, I would have thought the better way would be just to create a interface of the T-form object, and then you could inherit from that to the ibase dialog object, and then you could get all the type handling automatically, and you don't have to do all that string property names and stuff like that.
Yeah, that's fine if the form is already created and you happen to know, well, actually, no, that doesn't work very well then. Yeah, no, the whole point of the factory is it's about lifetime management, or at least it's about constructing objects without a huge amount of information about them.
Yeah.
So yes, you can put interfaces in forms without doing all of the rest of the stuff, and those interfaces
I
work.
mean, you'd create like basically just an iForm equivalent.
Yeah.
Which should be a pretty big to handle all the properties of a form, and then you can just access them via the interface. They'd appear on the interface.
Oh, well, actually, one thing when you're doing this, one thing that you should always do if you're putting an interface of a dialog or a form, that is to put this in. You need a property, or it could be a function even. So just say function. You will need that because forms do not get garbage collected. The nearest that you get is when the owner of that form dies, it will die. But if you've got a system where you're creating multiple instances of a form, then they're just going to all stack up in memory with no way to get rid of them until the application terminates, or until the owner of that form terminates. And if you've built this up as cascading, so the only form that's instantiated at runtime is the first one, then until that main form disappears, every instantiated thing is still in memory, massive memory leaks. So the way to get around that is you just surface the form itself. That means we need to put in here bcl.forms, and in the unit we need a function and in there we just return self. And that way, if you wanted to say, if we go back to our main form here, and I'm just going to put in another button. Button. Put a second button in here. And with this one here, we're going to if my class, if my form, got free, and if my form becomes nil. All right, so this one here will be cleanup. So what this does is it returns your form so that you can free it, and then you set the variable it stores it to nil. Now, this only works if you create it once. If you create it a dozen times, because we're not storing every instance of it in some sort of list, then we're overriding this variable, so only the last one will be freed. But if we were doing this more seriously, so that you could create lots and lots of instances, you'd want to store them in some sort of dictionary or some sort of list or array or something, so that you could then access all of the ones that have been created. But this here will clean it up. That there actually frees up the memory. This one here sets the pointer back to 0 or nil, so that you don't end up with access violations.
I was going to ask, well, I had thought before that when you were, because they're all, what are they, components, I guess, that when we're passing owner to the new, to the factory,
Yeah.
then the lifetime cleanup has been taken care of because of the way that forms and components and stuff work in cleaning themselves up.
Yes, except if, like I said, if you've created lots and lots and lots of the same form, there's no way to free them unless you do something like this until the application closes. So it won't memory leak, but if those forms are expensive, say, you know, a megabyte on the form, then every time you create another form, you're chewing up a megabyte of storage that's not coming back until that application closes.
I was going to ask if you weren't doing, say, components, like something non-visual, and your factory's creating things, what would the lifetime, again, this might not be the right point to ask this question, but the lifetime management, but then it occurs to me maybe you're going to create interfaces.
Okay, so
anyway,
right, so here's something that's quite important. If we go into my classes here, the base class here is a T-interfaced object.
Right.
T-interfaced object is garbage collected, and it's based on the let's see, it's the reference count time. You know, when reference count drops to 0, free. So T-interface object, that's the way that one works. So everything that descends from T-interface object, its lifetime is dictated by the number of references it has. And that means that as soon as your last reference disappears, it cleans up. Because your base form descends from T-form and not from T-interface object, it means that it's not reference counted. So this one here, this one uses the object, the form object hierarchy to maintain ownership.
Yeah,
So,
I got hung up on that a little bit early on because I was looking at that and because obviously it's an object that implements an interface. It's not an interface itself. And I was thinking like we got these functions and procedures that we have to implement because we implement the interface, and there's no add ref there, and I was like, and it like took me a while to like figure out it's the difference between, now I'm losing myself again, but like an object that implements. Nope.
Yeah,
I'm wavering on the edge of my understanding. Yeah.
All right. Okay. So forms manage the lifetime of everything that they own.
Oh yeah, I got it. Okay, yes.
So that means that if you create components, you don't have to worry about cleaning up components so long as they have an owner, which is a component. A form is a component, so therefore it'll clean everything up and everything's good. However, when you have something that isn't part of that descendant of component, that means you've got to have some other way of dealing with stuff. So when you've got, okay, so that's just interfaces. When you go to implementations.
The problem with my description before, I was saying object that implements an interface, but I wasn't getting either like interface smart object that implements an interface, or interface dumb, or like not
Yep.
seeing whatever object that's implementing an interface. Right.
Right. So what I've done is I've just gone to the reference of t-interfaced object. T-interface object is something that basically manages the lifetime of that object. And look at this. Oh, there's a class of t-interfaced object. However, there are other options that you've got for that are at this same level. I'm hoping t-aggregated object is another one of these interface well, it's another option for what you can descend from, and its behavior is slightly different. Luckily you have this lovely documentation here that tells you exactly when to use it, so that's very helpful. You've got t-contained object, which works the same sort of way. There we go, t-no-ref-count object. T-no-ref-count object works the same as, or very similar to, I should say, as a t-form, in that you have to manage the lifetime.
Yep.
And what that means is that at some point your interface is going to have to give you a way to free it, because without reference counting, interfaces don't naturally kill themselves. So then with this, you've got all of these lovely little, they're not compile directors, what are they? They're attributes. So you've got these attributes, things like unsafe or weak or things like that, which manage things that are reference counted. In this case here, it's saying that the controller, this here, when you assign something to that variable, it does not increment the reference counter. But the difference between unsafe and weak is unsafe does not check to see whether or not your object still exists. An unsafe variable, you can go to it and say, I want you to do this for me, and it'll say, sure, I've had a value assigned to me before, I'll just do that. And if that memory space is being cleaned out, then you get an access violation. Whereas if you have weak says, I still want enough of a connection between that object and this variable so that when that object is freed, my variable knows that it's been freed. So therefore you go and ask it to get whatever's at that reference, and it returns nil because it's been zeroed out, because it's been cleared up. Now, there's other nuances between unsafe and weak. It's not just about performance, but yeah, there are things where you can use an unsafe reference count where you're not allowed to use a weak reference, not reference count, weak reference attribute, or a unsafe reference attribute. And unsafe is more flexible, it can be used in more places. So anyway, that's, yeah, one thing we need to absolutely establish in our minds is that interface is purely a contract. All that nice cleanup behavior isn't because of interface, it's because of descending from t-interfaced object. So it's still the class behind the base class that determines the behavior, like reference counting. There's nothing intrinsically great about interfaces being reference counted. That they aren't, not intrinsically.
I feel like that's a really great point that I hadn't clearly separated in my head before now. Like the object does part of the job, and the interface does part of the job. And I was thinking of them as together,
Yeah. The interface, think of interface as purely a contract. It's a contract that says I need to implement these methods. If I implement these methods, I've met the contract. And then what you can do is you can query something and say, do you have this contract? And it'll tell you yes or no, because it's either been defined with iWidget. So if you ask it, do you have the iWidget contract? It's going to say no, or it's going to say yes. If it's yes, then you know all of the properties and methods and so forth of iWidget will be active in that object.
And that's why we need the GUIDs, is like you can't get that
Yeah.
info, is that right? If you
Okay,
don't
yeah,
have the
so
GUID?
Yep. So here, this here is the GUID that references or is synonymous with this particular interface. So in the system, the iWidget is for our benefit. That's what we call it. As far as what the system knows it knows it as this GUID, and that GUID is managed within the RTTI system. So you can ask it for that GUID, and it's the same as asking for that interface. Or wherever you ask for an interface, you can put that GUID in and you'd still get the same interface.
Can I,
If
can
you
I-
copy,
sorry.
yeah,
Go
if you
ahead.
copy the same GUID into two different interfaces, chaos will ensue. Yeah, it'll choose one of the two, and everything's going to be that. So never copy your GUID reference.
Richard, are you still there? I'm sorry if I caught you I was just wondering if in C#, because they have garbage collection, right? In C#.
Yes, they do, but it's a different sort of garbage collection.
Yeah. Not our way, but so then because people have argued before that our interfaces, because they kind of mix together lifetimes and contracts,
Mm-hmm.
it kind of like a little bit complicates the mental model. And I wondered if C# might be just straight contract,
Yeah,
or not? Are they still reference counted, do you think?
I have no idea.
We can ask Richard at some. What
Yeah,
do you think?
I'm sorry, you've just gone out of my knowledge areas. All I do know is that because they don't use ARC, which is automatic reference counting, they don't clean up the same way that ARC does. The way that ARC works, automatic reference counting, is that as soon as that reference count drops to 0, it begins the process of freeing, and it's right there, it's immediate, which means that as soon as you drop all references to 0 for that object, it's going. If you're descending from T interface object, and that did go for when you're doing stuff on Android or iOS. It did the same reference counting, but they've removed that in one of the more recent editions. So now when you're writing for Android or iOS, you need to explicitly remove items. It won't automatically reference count its way out of there. Now, the reference counting that you've got for C# is there's an internal garbage collection daemon that just sits there going, is this one, can this one be freed? And it just goes running around trying to work out if something can be freed. And if it can, it then goes and deletes it. But because it's this little daemon sitting in the back somewhere, it's polling memory. And it may eventually get to the point where it says, yeah, I'm fairly certain I can get rid of that, and it kills it. But that it's completely disconnected from the last reference disappearing, which means that you don't control the lifetime of your objects in C#. I've run out of counts of this object. Some point in the future, perhaps maybe it will get rid of it. And depending on how sophisticated that little daemon is sitting in the background, maybe it's going to be closer to now than previous versions.
Hi, Richard. Did you hear what I was asking a minute or so ago?
I
was a
caught the
C-sharp
last bit
question.
of Scott's reply just now.
Yeah.
I was just wondering. I was saying that people have said in Delphi, interfaces kind of combine lifetimes and contracts together. And my question was in C#, because you've got the garbage collection, does that mean interfaces aren't reference counted, or does it look similar, or?
Yeah, I just need to butt in for a second. Hey guys, just need to butt in for a second. I'm taking off. I'm gonna make you host Paul.
Sure.
Done.
Yeah. Thanks, Scott.
Yep. Okay, see you guys.
Yeah.
You, Scott?
Yeah, so-
it's Vandalin just the back. I'm gonna make you co-host. Oh, hang on, that won't let me more because I'm not host anymore. Okay, yeah, it's just Paul.
I'll
You're
do
the host.
that. I'll do that.
Yeah.
Okay.
Right.
I'll figure out
So
how to do that.
okay, so
I think
you've got the idea,
my
Richard?
guess would be in C# my guess would be that in C# the two functions are separated. So so the interfaces are just contracts and the garbage collector, because all objects in C# are garbage collected.
Mm-hmm. Yes. So what we're asking is that the way that Delphi does it, and this is basically, well, the reason why Delphi has the whole T-interfaced object is to mimic the reference counting system that you get with COM.
Yep.
So you remember that to communicate outside your app, you needed to use COM or decom later on. And that system used an automatic reference counting type of scheme to get rid of
I think the reference counting
interfaces.
Yeah, I think the reference counting part of the interface contract is definitely restricted to the interfaces, but then you've also got the garbage collector actually physically cleaning up the memory.
Yeah.
So the reference counting in the interface will say this object is as it has an interface, it's reference counted. You can't get rid of it until the count gets to 0. But the garbage collector collects all objects anyway. So it tries to work out. In the case of interfaces, it says, right, I know this isn't used anymore because the count's gone down. Whereas with ordinary objects, it's sweeping around and trying to find out whether they're still in use.
Yeah. Yeah. So yeah, I guess that's sort of the same thing as I was saying earlier with it's a little demon in the background that just sits around trying to work out what it can get rid of.
Yeah. Yeah.
And as a result,
and it also
there's a
does it on.
disconnect.
Yeah.
You
It also has
lose-
different heaps.
Hmm.
So it has different heaps that it puts the objects on when they're created as well.
Yeah. Now, when it came to, and this is the big controversy that we had with the whole garbage collection inside Android and iOS versus Windows. So we had the same sort of garbage collection happening. Like it was using Arc, but it was in the Android model and the iOS model, it would automatically garbage collect using the Arc model. So you'd never had to free anything inside Android or iOS development. But they promised to do that in Windows. It failed because of COM. Because when they went to do the whole changing the way that the system was, using memory, they started trying to make all Delphi objects work the same way. And then they ran into some incompatibility with COM. And because they had to keep that backwards compatibility so the COM still worked, they couldn't do reference counting ubiquitously across every object. So they scrapped it, and then it got so bad that they reverse scrapped it into iOS and Android. And I think it might have been, I want to say it was one of the Delphi 10 point somethings where they actually stopped doing garbage collection in automatic garbage collection in Android and iOS.
I think it was either Tokyo or Rio because it was there in Berlin.
Yeah, okay, that sounds about right. I know was one of the later 10 points. All right, so I'm pretty much close to the end of what I was hoping to get through tonight. Are there any questions?
Well, naturally, Big Mouth here,
Scott.
that's
Oh,
me, has some questions, but you please go ahead, Richard.
Scott, here's something that's a bit missing from interface examples in Delphi on the net generally,
Mm-hmm.
and it was something I didn't know about for ages until one of my colleagues pointed out to me. It's actually really simple.
Yeah.
It's how you get a class that references more than one interface. How you cast between interfaces. I know how to do it now, but there aren't actually any examples out there.
That's it.
But when you if you create an instance of iWidget and then cast it to
Yeah.
something else.
Yep. Hold on, I just need to put an something else in here.
Yep. I know how to do it now, but at the time I was learning about it, there was just no information out there.
Okay, so one thing I should mention, everyone knows the shortcut for getting a GUID. It's Control Shift and G. Just generates that GUID text there. So anyway, yeah, when you're using when you want to have multiple interfaces implemented, you just put it on the list here. So just after you've got your class defined, everything after that is another interface that it supports. If you've got two interfaces that have the same, say the same method or the same property, but you want different implementations for it, there is also, and I'm forgetting how to do this, I think it's like you implement this function as this interface's what have you. I'm trying to recall what it is. I can't quite remember the syntax.
Yeah, that's correct, Scott. Yeah.
So what you
You have to
can
do that in
deal
the
with,
declaration.
yeah, it's in the declaration, and that's the way you get around stepping on two interfaces toes when they both implement the same method or property. There's also another one that you can do where you say that you could have an object that you've aggregated into your class that supports a particular interface, and then what you can do is you can have a property and of that type, and in that property at the end you put implements and then the name of your interface, and that implements name of the interface. Actually, I think it's implements. Okay, well, one at a time. So if we do this, so we've got a mutant class we do here. Property. So we just need it's property X, and that's an I something else. And then we probably want a getter. Get X. And then I can't remember if it's a semicolon or not. And it's going to tell me in 5 seconds. Oh.
The Embark, the doc wiki has got like under interfaces method resolution clause. Is that the same thing? When a class implements two or more interfaces, and you can do it, bit like enums. You can give the interface dot x and interface 1.x and interface 2.x as well as what you're doing.
Okay, so there we go. So we've got widget mutant, I something else, and then we've got I something else here as a property. We need the getter, and then implements something else. And of course, we could do this if we had, I think you can also do this if you just have a reference to the variable like fx. That also works. Now, what were you saying there, Paul?
Sorry, I was just looking on the doc wiki, and under interface implementing interfaces, it comes to method resolution clause.
Yep. Yeah,
and
so that's something like
you can do like interface 1 dot print and then interface 2 dot print sort of thing.
function I something else.
Dot.
So we need to go to that there.
I think that was T widget, wasn't it?
Oh, sorry, did I put that in the wrong one?
I think it was maybe T widget.
Ah, whoops, yep. Good pick up there, Paul. All right. Something still not happy about that. Oh. Equals, and then
Oh yeah.
like that.
How about I just send you the link?
Cannot have method resolutions for I something else. Is that because of this? Undeclared identifier something else print. Oh, do we need to do this again?
I put the link I was looking at in the chat. But the one that you were just doing with the properties is on there, implementing interfaces by delegation.
All right, so there we go.
Unless
And if we do this,
unless I'm misreading that.
something's not quite right there. Is it just that?
Is it,
Okay.
Scott? Oh, right. Sorry, I was going to suggest maybe the other way around, but if it's worked, it's worked.
We shall find out. Where's that link? I need the chat. Give me the chat. Where's the chat?
Yeah, I think that's what it was saying basically.
I have a few things open. All right. Implementing interfaces. Method resolution clause, procedure interface dot method equals implementation method. Yep, so that's precisely this. Close that. How do I close that without closing the meeting? Maybe I'll just put that over here somewhere. All right, yeah, so this here, when you've got conflicts, don't call either of them by their regular name, and then this here, it looks like it's a function, but it's not. What it's saying is that the print function of I something else is actually implemented by something else print. So that's where you do the tricky ones where you get stuff colliding. But the whole point of this sort of thing is because Delphi does not, unlike C++, does not have multiple inheritance. So when you've got a class that really should be inherited from two, just like your children in an emergency, choose which one you love best and save that one, and the other one you have to redo.
Scott,
Yep.
let's create a T widget mutant, store it in an I widget, and then cast it to an I something else.
Okay. So you were just asking for a widget mutant to be something inside a
To be
widget.
stored inside an I widget, and then later in the code, cast it
Mhm.
to an I something else to use the I something else interface.
Okay. Is this a gotcha or something? Does it cause something to explode? Because that
No,
seems
it
very
works.
circular.
It just shows this is the example that wasn't on the web.
Right.
When I was looking for examples years ago, I could get examples for single interfaces,
Yeah.
but there wasn't an example where you created an object as an interface and then cast it to another interface that it supported. I couldn't find one anywhere.
Oh, okay.
I've done it. I know how to do it, but it's for everybody else.
There's actually two different ways to do it. One way is a lot more correct than the other way. So if you, let's go to the main form here. All right, so we've got here, I need an I something or other. Where do I get the I widget, F widget. So F widget, now if we go to my classes, mutant is also an I something else. So what we can do is that inside, where is it? Inside this here, my class facts, we've got a property widget, which is that there. Now, if we wanted to, we can do something like function something else. And in here, we do, now the best way to do this is if supports, if widget, I something else, result. Actually, you don't need the if, oh no, sorry, if not supports, and then result becomes nil. So that'll work. So you've got a widget, it may or may not support something else. If it does, then set the value in result, which is I something else. Otherwise, you set it to nil so that it's like not supported. So that's the most fail-safe way of doing things, especially if there's a possibility that your original object may or may not support it. The other way to do it is result becomes if widget as I something else. There is an implicit test in the as cast, which does the type checking to make sure that that's possible. It'll raise an exception if it fails. And the exception is going to be that the type is not correct. The third way to try is result becomes I something else. If widget, not, okay, so in order of recommendation, this here is top quality, this here is not too bad, this one here stay away from, it's likely to cause you issues.
Cheers, Scott. That's exactly what I wanted. Yeah.
All right. One other thing, and I'm just at the moment, the Delphi has a bit of a funny thing where if you have a descendant, so one of the things that interfaces can do, similar to classes, is you can have equals into come on you equals into I'll get this right sooner or later. Right, so I've now got a mutated widget interface and it descends from iWidgets. So this is basically the same way that classes descend from each other. Well, you can do the same with interfaces. An interface can descend from another interface and it collects all of the stuff that's in that interface. Now, if this does something like property A, and this one here, we have and then it's going to be so if we have something like this going on, and now this is something that I ran into the other day and it caused me a huge amount of grief. If you have something like this going on where you've descended from one interface and then you've added more functionality into your interface here, there's a bit of a gotcha. And there's something I haven't actually reported this, but I think pretty sure it's a bug that if you do something like widget becomes, and then it is factory mutant, like that, F widget is of type iWidget. So if we later on in some other code, so we just do some other code. Hold on. Let's get this right. In here, if we do if widget as I is that right? I something else. Mutate is mutate. What else have I got wrong there? Mutated widget, not mutant widget. X-Men. It's a mutant widget. All right, this here, if I then go dot print access violation. That fails because this here returns nil. The way to fix that is if we go here and we get that fixes it. Oh, sorry, I'll need to do this. If we do this, everything is hunky-dory because it's actually been a mutated widget. But once we leave here, and the only living trace of it wasn't ever a mutated widget, then it can't ever be a mutated widget. I'm pretty sure that's a bug. So is everyone following what I'm doing here? In order for f widget to be a mutated widget, it needs to have been a mutated widget. If it's never been a mutated widget, then this here cannot be cast at some later stage. And I don't understand why doing it here in the middle of creation is fine, but doing it here is not. All I know is that that is actually what's happening. And my fix is precisely you cast it as its descendant type first. So hack, you cast it as that type because of hack, and now everything's working nicely. It's crazy. And I can't tell you why that the hack works, and I can't tell you why it's an error. In reality, it should just be that you go back to the original object and you look through its interface lookup table, and it says, yep, everything's fine. Here's your memory space. It doesn't do it for some reason, and I cannot work out why.
Is this related to an object that implements two interfaces? Is that what's happening here?
No, what it is, well, it sort of is, because if you look at this here, you've got iMutated widget, which is a widget. Now, when you implement something, like in my classes here, and you say, okay, so this here is, actually this is a bad example. I'm already muddying the waters by using this as well. But okay, so say this one here is base class, which implements something else. Actually, I don't know if this makes a difference. If we take that out of here and put that in here, I don't know if that makes a difference. It may do, it may not. But anyway, yeah, when you do that cast, things can go awry if you don't do that little two-step in there.
I don't know if this is related to that. I had a question, like from when I was first trying to, mess around with interfaces and figure out, because an interface is a contract, but then you've got to make the object
Yeah.
to suit the. So say you have two interfaces, and one interface has functions A1 and A2, and the other interface is B1 and B2.
Yeah.
Then you've got an object that implements both of those interfaces. So it's got A1 and A2 and B1 and B2.
Yep.
And you can make a variable which is of type object, right? And you can see everything that's in that object.
Yes.
But you can make a variable that's of type I interface 1.
Yep.
Right? Where you create it using that object. But now, because it's an interface reference, you can't see inside all of that object, can you? You can just see A1 and A2.
Yep.
Your interface 1.
When you've got a variable of type interface, the only things that are available to it is what's in that interface.
Right.
But you can also ask it if it supports other interfaces, and you can also cast it back to its original type using the as clause.
Yeah, well, that's what I was wondering. If you went I interface 1, but cast it either in 1 step or 2 steps, I'm not sure.
Yep. So what you can
When
do,
interface 2, it would know those things are still in there and still be okay with changing.
Well, the reference you got to interface 1 will still know about the interface 1 methods, and the reference you got to interface 2 knows about the interface 2 methods. You can use them as 2 different instances, but you can still see everything.
Right. So the object that has the concrete like gears and gears, it's a concrete implementation. It has everything
code.
in it.
Yeah.
yeah,
And the interfaces
Yeah.
are like looking in through 2 different windows at a house or
Correct.
something.
yes,
And the
Yeah.
house stays the same. but
Yep.
the
House
windows,
stays the same.
right.
And when
Yep.
when you finish using all of them, the house gets freed up.
yeah. If you're using T interfaced object as your descendant class. Oh, sorry,
Right.
as your
Thank
ancestor
you.
class. Yep. So you can do this. You can say F widget as T widget, and providing it is a T widget, that's all going to be nice. If it's not a T widget, then you've got problems. But yes, you can do this. You can get it back to its original shape. If you wanted to get from F widget to what's the other one? F mutated widget or what have you, you can do supports. So F widget, now there's multiple different overloads of supports. This one here, when you don't have the third item, is purely asking, do you support it? But it doesn't actually do anything else. There's another one. Okay, so if we just look at the different overloads of supports, you've got the one where you've got the IID, the GUID, and an out of the interface of that IID. So that's one way of using it. You've got another one where you have, okay, so there's the interface, the objects, because objects can go through supports as well. You can get the supports of an interface without an out variable, and it just returns whether it does support or doesn't. And the same thing for if you've got an IT object or an interface. And then there's a class, and you can just ask it if the class supports it as well. I'm not sure if you can actually see that on the screen. It's really, really small. My apologies.
Yeah, we can.
But yeah, there's 4 different supports or 5 different supports. And this one here where you're not doing anything, getting anything out, is purely saying, do you support this interface?
That seems like a particularly like the out parameter version of that.
Mm-hmm.
It seems like it doesn't support like composability, right? You can't like it's not a function that gives you like it gives you the boolean, but it's not giving you the result. Like if you wanted to turn one thing into the other.
Excuse me, folks. I've got another meeting starting, so I've got to leave. But
Thanks
No
it's
worries.
been
for
great.
hanging with
Thank
us,
you.
Richard.
It's been great being with you. And please, let me know about your future meetings. I'd love to join in.
Oh,
And we'd be pleased to have you.
I've put you on our collection of emails, so whenever I send out anything to our group, it'll come to you until the
Brilliant.
end of time
Thank you
now,
very-
Richard.
I'm a POMI affiliate to the Western Australia Delphi user group.
Absolutely.
Sounds good.
On the Reader's Digest, you'll be dead 10 years before they'll stop.
Hey, and
Thank you
Lee,
very much, guys.
While you're up there happily smiling, as I'd like to say hello to you, which I didn't when you first came on.
How are you,
Hello
mate?
from John.
Hello, John. How are you?
I'm okay, mate. Yes, I am.
I think he snuck in the back door.
I just been cooking slowly.
And greetings. I'm not sure how to pronounce summer. Is that correct?
Oh, you're muted.
Oh, you're muted.
Uh.
You're on mute, buddy.
Sama, you're on mute.
That's it.
Can you hear me?
Yes.
We can hear you now.
Good.
Yeah, good. Yeah. My name is Samer.
Summer.
Samer. Yeah, you say it correctly.
Thanks for joining us.
And my thank you.
Where are you joining us
Um,
from, Sama?
Actually, I'm in Turkey.
In
Turkey.
Ah,
Yeah, in Turkey. But I'm Syrian. I'm not from Turkey. I'm in Turkey.
Well, it's now official, guys. The WA chapter of ADUG is now gone international.
absolutely. Yep. Yeah, welcome, Sama.
Nice
Thank
to
you very
meet
much,
you.
guys. Take care. Have a good day.
Thanks.
Okay, see you,
Good
Richard.
Richard,
one.
thank you. Welcome anytime. And yeah, Summer, same. Like, I hope you've been finding it interesting.
Yeah, it was interesting, but I'm a little bit busy. So I'm listening a little bit and work a little bit. So
Yeah,
I'm in
It's all-
between.
it's all being recorded, so I think there'll be a lot in
Yeah.
here for us to look at.
Yeah.
All right.
A lot.
Okay, so Paul, you wanted to know how you would use this form of supports. So we've got here supports F widget, which is an I widget. We want to know if it supports mutated widget, and if it does, it'll put it into X, and then we can do X, which is a mutated widget, dot mutate dot print, because mutate turns it into an I something else.
Yeah. No, I was just kind of complaining that, like, the oldest vestiges of Pascal that we have, like is it str or for turning it's either for turning an integer into a string or a string into an integer. It's like
Yep. Oh
it's a
yeah.
procedure, and you got like maybe it's integer and then string and then an E for error, right? And it's not
Yep.
composable because it's just a procedure, and you just like it only works on its own, and then like it's very, very, very procedural code, right? And
Yeah, and it runs or plays fast and loose with its types.
and now we have like x dot to string or like dot to integer, and then you could have like dot something else, and
Yeah.
like it's very nice and very flowing, and yeah.
So right line P1, P2, and the type is not stated, and neither is the number of parameters. That sort of thing. That's right line is just dodgy. It doesn't follow any of the rules of Pascal. It's something that Turbo Pascal added. I'm pretty sure it's not the way that we use it is not the same way that it intrinsically was when Nicholas Wirth wrote Pascal.
Oh.
But then again, strings were not in a thing in the original Pascal. It was an array of char. So yeah, we got a lot of things from Turbo Pascal, and it's just sort of continued on. This right line abomination is one of them, and the str works almost the same way. I mean, look at the way that the syntax works for this. I have pi. Let's just do pi. And then you can do colon 5 colon 2 and then S, where S is a string. I mean, what in the world do you call this? Oh, and sorry, we've got an error as well.
Yeah.
And I forget what error is. I think error is an integer.
No, you're missing a bracket on the string declaration.
Oh yeah, sorry, yeah. Oh no, that's right.
Next
Error is
line.
not Error is not necessarily a copy of that. Okay, so there we go.
Oh, yeah, val is probably the one I'm thinking of. Val, you know, what is it? String, integer, error.
No, it's just the line above. The line above, you're missing that Oh, hang on. Yeah, you're missing second bracket, I think. Oh, no, you're not.
I
No.
want something inside the right line.
Yeah.
Yep. And your val is a string of, actually, no, that one there actually follows regular convention. You've got a var parameter, v, and a code. But so val is sort of, it's following regular things. So we can do 5, and then I, and then code. So that's this one here. Now the interesting thing about var is that it is untyped. So you can actually put anything into that one there. So I guess the thing is we can have untyped variables, and they actually are just literally there's a type for untyped variables.
Yeah, untyped function parameters.
Yeah. If you declare a function and you forget to put the type in, or a method, doesn't have to be a function. Procedure X. Hold on. A string var X.
There's no name for that procedure yet.
Oh, yeah. Okay, that's good. Expected. Where?
The procedure doesn't have a name.
Oh, yeah. Sorry. Oops. Been writing too many. Yeah, but there we go.
Anonymous procedures.
Yeah. So here, this here is an untyped parameter, and the untyped parameters are actually a type. So it looks like a hack. It looks like something that is wrong, but it's actually right, which is really bad because no one does this anymore. And it just means that you don't get syntax checked when you do that. But yeah, this is literally give me anything and I'll work it out once I'm in here. I think the other way you can actually do this as well is that correct? What's wrong here? Oh, I see. And what's this here say? Oh, sorry, it's array of const. And I don't think you can have a var array of const, or can you? Yeah, so array of const gives you an array, and it's an untyped array. So it's actually an array of the same type as that other one we had, which didn't have a type. Which means that you can actually investigate what it is. And I forget how to do that at the moment.
Array of const can have different types in it, can't it?
Correct. It breaks all the sorts of rules. And really, if you're going to do write line, this is what write line should look like. It should actually look like array of const. And then when you use write line, you should actually get rid of that. So that's what write line should look like. Or maybe file. And you'd have to have an overload.
I guess then we'd have to use the square brackets inside the round brackets.
And then it's file of a file of type file, and then X array of const.
I think there is a function called format to format a string. It uses array of const.
Yes, it does. But what I'm saying is this here
I think
is
it's a
this
const.
is this is legal Delphi, what I've written here, the way that you use this, and it's consistent with format. And if we wanted to use format, let's get rid of that for a moment. Then we have some text in here.
Const.
I forget, is it $%?
Yes.
And then you would
S for
have,
string, D for integer. Yeah, exactly.
so that is format, and that's the way it looks. If we were to do write line, it should work the same way, where we do open bracket A, B, and 5.
You don't need to go that tight.
Now that's the way that write line should work if it was written using proper Delphi. But instead, if we get rid of these overloads here, that is not how you do write line. Write line is this abomination here, where it is that is legal. Now tell me what rules in Delphi allow you to do something like this, where you can just keep on adding more constants.
The rule of cool.
I mean, that's legal Delphi, except that this syntax doesn't exist. You cannot make a function that works this way.
All right, okay.
It's
If
just,
you put the square brackets on, it'd be okay, right?
yeah. This way here would be the way that we would implement write line today. Where you'd open a square bracket, everything would be in there, and you close the square bracket, it'd be done. Or if it was a file, you would add the file as the first property followed by the array of const. And that would be how you should do it. The way that you actually do it is we pretend we're dealing with an array of const.
I think what you're saying is that you want Delphi to have C++ variadic parameter packs.
No, I don't. I just what I want, and the thing is they can't do it because Delphi is highly committed to backwards compatibility, even if that backwards compatibility goes into Turbo Pascal. Because this has lived forever, it will continue to live forever and break every Delphi rule.
If you go to system unit and there is a node there, predefined const types, procedures, and functions such as true, integer, or write line.
Yeah,
Do not have actual declaration.
exactly right, because you cannot do write line.
Mhm.
It's a hack. You'll never see the source code for write line.
They said instantly they are built into the compiler.
Yeah.
And are not treated as if they are declared at the beginning of the system unit.
Yeah.
So it's like built in something.
Yeah. It's the major hack that everyone winks at and tries to forget.
Yeah, and which one we can do.
Yeah. So yes, we just live with these eccentricities, and it's good to know this stuff just in case, like me, you run into some programmer that probably 50 or 60 years ago did Turbo Pascal in high school, and that's his entire sum of programming education. And so he's still treating Delphi like it's Turbo Pascal 3. And yes, I've got that. I've literally got write lines. They use the str function just precisely the way we do here. And it's such an abomination because you can also do str and then 5, give it one parameter, and then s. And that is also legal because this one here, 5 is the value, which is an integer, and you're telling it has a width of 3. With this one here, it's a floating point number, so you can specify both width and precision. And it's like, oh, guys, don't do this to me. But yes, this stuff here, if you ever run into someone who's, you know, programming is the thing that they do on the side, and they're actually an engineer or a physicist or something or other else, and they've did Turbo Pascal when they were back in high school, that's where you'll run into this, and hopefully nowhere else.
I remember those discs from Borland. It cost $25 for the whole Pascal deal. Wasn't even worth going out and photocopying the stuff or pinching it. You got the book.
Yeah. Well, I'm afraid to say that being a dumb teenager at the time, I actually got a pirate version of Turbo 4. And I never actually bought Turbo 4. My first purchase of Turbo Pascal, I think, was 5 or 6. And I did that when I went to uni.
Yeah.
But the interesting thing was that they improved the compiler so much between Turbo Pascal 3 and Turbo Pascal 4 that when we were in class and I was using Turbo Pascal 4 and the rest of the class was using Turbo Pascal 3, we did an assignment to see how fast our algorithms could work. And the optimization was so huge that I wrote practically the same code as everyone else. But whereas theirs took like 20 seconds, mine was almost instant.
Yeah.
And so I gave myself a secondary assignment. I went through, researched all of the frequencies of notes on a keyboard. In Turbo Pascal, you could tell it to beep at a certain frequency. So I wrote something that would actually parse a bunch of notes and play a tune by making it beep for a certain amount of time at a certain frequency. And so after running my simulation, which ended like, 20 seconds before everyone else, I got it to play the Looney Tunes theme while we waited for everyone else to finish.
Yeah, amazing stuff, wasn't it? But
Yeah.
of course, you're running it on a good operating system back in those days. DOS, that was fantastic. It flew.
Yep, 3.1. Was it 3.11 or something?
Yeah, something like that. Yeah.
Well, yeah, DOS 3.11. Yeah.
We switched from a project that I was running. We moved it from DOS to Windows, and at about a quarter of the speed. It was just dreadful.
Yeah. And it's still very bloaty.
Would have gone straight to Linux if it was invented at the time.
When you say moved to Windows, was that Windows 1.0 though?
Something like that, or Windows 95 or something. We really resisted it as long as we could, but not Windows 95. I think we moved it over to, and it ran like a dead dog.
Yeah. Yeah.
It was a process control system that was running on DOS. It was fantastic. Yeah.
All right. Was there anything else we wanted to cover tonight, or any other questions or comments?
All I wanted to say was that was fantastic. A great presentation tonight. I almost learned something.
Well, that's okay. I almost taught something.
That's great, mate. Excellent job.
Yep.
And Scott, I learned heaps from you there, bud, and I'm going to go over it probably 2 or 3 times. And because I've been meaning to get into interfaces for some time. I read pluses and minuses about them. Like people say, oh, you should use interfaces. They're magic and all that. And other guys say, oh, they're no use to you at all. Variety of comments on them, but I have been meaning to get to grips with it. And your presentation tonight here is just sort of, it's been brilliant, mate. Brilliant. What else can I say? It's just been great. So thank you for your time, because you certainly put a bit in there, bud. That yeah, great.
Yeah, no worries.
And Summer, we'll put you on the list, will we? Summer,
Summer,
I'd
we
like
put
to.
you.
we'll put
I'd
you
like
on the
to-
list for next.
I'd like to emphasize that I rang Scott, what, yesterday?
Yeah.
I'm
Yeah,
like,
it was
I
about
have
9
nothing.
9 p.m.
I have nothing for the meeting, and he came up with this. So there you go. Like,
Well, you kept us going for what, just on 3 hours there, bud. It's got to be a record of some kind. So,
Well, thank you very much.
Riveting, mate. Fantastic.
Yeah.
awesome.
My ability to waffle is unprecedented.
No. Terrific, mate.
Oh, but it's good waffle, mate. It's good.
You're a
waffle.
good teacher. Excellent, man.
It covers the bounds of the universe.
Yeah.
Interesting.
One thing I wrote down here, when you know how you went through first you introduced using T-widget, and then you went to T-widget, T-widget class, and then you went to T-widget function, a function that returns a T-widget. Like, that really tickled my brain, because
Me too. Yeah.
I've said to people before that, the Lisp people are fond of saying, like, code is data and data is code. That. So you can have the number 5, or you can have a function that returns a 5.
Yeah.
And if it takes no input and returns a 5, then these are they're very much similar to being exactly the same thing. And then you basically put it straight on the screen there in a completely different context than, how I'd thought about it before. And I like that.
Yeah, and look, there's reasons why these programming principles have stood the test of time. I mean, I learned about cohesion and coupling back in my Turbo Pascal days, and obviously object orientation was nowhere near Pascal at the time, but those principles still hold out true. You still want to have loose coupling and high cohesion, because it makes more understandable code, more flexible code.
If you get into something like Pascal Analyzer, does it tell you about coupling? Does it give you a list of things that are like loosely coupled or tightly coupled or whatever?
I don't know. I would hope it would, but those sorts of things would be hard to detect, I imagine, because it's something that any human can look at and go, yeah, that's really coupled. But how would you write a simulate or a language parser that would say, yeah, I can see some coupling here that ought not to be? I guess one way to check your coupling is you, like I said before, you just look at your users clause. Now, we don't even have an implementation users clause, but you look at this one here, and what you see in main in this loosely coupled form is everything here is system, or is built into the system, or a library or something, except for that.
Yeah.
One unit that you're using to link things together.
Yeah.
The rule of thumb is the more things that you put in your users clause from your own code, the more tightly coupled your code is going to be.
All right.
I have a question from a long time back, I guess. So when you declare a class, just looking on the screen there, that has a field, right? And then you have a property.
Yes.
Let's say it's a read-only property that. Okay, that can't.
Okay,
I'm
so
answering
this one
my own question as I speak it out.
Yep.
But like,
so this one here, that's your read-only property. Yeah.
Right. So I mean, like, okay, that's definitely got a function, because if you exposed the field, people could get in and change it, and this enforces it as read-only, right?
Correct.
often you'll see someone property widget and it's read and write, and it just refers to the same field.
Yep.
So to my mind, at that point, it doesn't give you any advantage, but is it like people building something in for possible future change, or
It could be. The other thing that this gives you is that when you've got a property, then you can use RITI to access that property. It's a lot. There is an equivalent way in the new RITI of connecting to fields. It gets more difficult when you have fields sitting back here somewhere. But yeah, this sort of thing, this is very, very trivial. And the only time I would do something like this is if you also had an implements iWidget. Something like that.
property can,
Or you have default. And that would be, you can't do it with T widget, but you could do it with a basic type like default 5. And that would work if this here was an integer.
right.
So, and the reason why you would do that is because those things, if you're descending from a persistent, T persistent, they will get stored. So a T persistent, when you stream a T persistent, it will store anything that is a property, except for if you've got default, and the default value happens to be the same as its actual value. Then it sort of suppresses it, which is the whole point of default. But yeah, this stuff here, the reason why I don't tend to do this very much is because interfaces don't allow you to have fields. So you're always, whenever you're dealing with interfaces, it's always going to be a getter and a setter.
Yep.
But you're right, you can have read-only fields. You can also have write-only fields. You can, that's also legal. Which is sort of interesting. You cannot tell what the value is, but you can tell it what to be.
That's like wildly flailing at a light switch. It's like, my intention is that you should turn on, please.
Yeah, it's the light switch that you flick it on, you flick it off, and it doesn't seem to do anywhere in the house. And so every once in a while, you just, as you go through a room, you just flick it on and flick it off. And eventually you get a call from someone in China who says, stop that.
Excellent job, mate.
Yeah, that's great. Super, super great. And we're right on the 10 p.m. Just about.
Oh, and that's when I turn into a pumpkin.
Can we can we stay and watch?
Yeah.
Well,
No,
Jerry's at the front door. I think we better go.
all right. Anyway,
Well, that's fantastic, Scott. And I think a lot
thanks
of
for an
people.
enjoyable evening.
Thanks again, Scott. Fantastic.
I think a
job.
lot of people will be keen to look at that.
Yep.
Yeah. Good job, mate.
KW was one of them. Yeah, cheers for that, bro.
Yeah.
All right. Just remind people next Monday is the AGM, ADUG AGM, and
Oh, okay.
David Millington talking about his AI code understanding engine.
Mm-hmm.
And I'll get off my ass and actually post a bit where he spoke to us already on the forum.
Yeah.
I've been dragging. And other than that, unless anybody has any questions or statements. Oh, Peter Wright. Hey, sorry, I didn't see you there. And thank you everyone for joining us, and we'll call it a night.
All right.
See you all later.
Catch you later.
Thank you all.
See you, Sammer. Good to meet you.
Yeah,
Thanks again,
See you
Scott.
next time.
you too.